We'll start. Yes, shall we start? So what we studied last time? Different types of restoring forces. Then we studied Newton's first law of motion. What was Newton's first law of motion? Any body in the state of rest or uniform motion will be in that particular state until an external force is applied on it. Based on that, we have done some around nine applicative questions. How the rider falls backward, forward when it starts running, moving. Okay, so that was based on your first, Newton's first law is based on inertia. Now, second topic that we are going to study is, what is this? Momentum. So do you all know what is momentum? You know how it is denoted? There's a alphabet P. Momentum is denoted by alphabet P. Okay. Do you know the formula for momentum? It is mass into velocity. It's a vector quantity. It has magnitude as well as direction. Vector quantity. So how you denote it? With an arrow. So here also will be arrow. Now can you tell me what is momentum? If I'm walking, do I have momentum? Yes. So any object that has mass and is moving will always have momentum in it. Is that clear? Okay. What will be the unit, SI unit of momentum? Mass is kg, velocity is meter per second. So SI unit for momentum is kg meter per second. Note down. Written. So based on momentum, you will have Newton's second law of motion. Okay. Newton's second law of motion. आता न्यूटन सेकंड लॉ ऑफ मोशन याद दवरपाक एक concept याद दवरा of a cricket ball and a bat. Okay. So suppose there is a batsman over here. Bat asa. There's a ball which a bowler is throwing. The ball has some mass and it will come with some velocity. Ball bat akade nailo with some velocity. What will happen when the batsman hits the ball? What he is exerting on the ball? Force. So how ball angailo? The batsman will hit the ball, so he is exerting what? Force. Because of that force exerted, what is happening to the ball? So it will say start moving something like this. In different direction. Will the mass of the ball change? No, it will remain same. What will happen to velocity? This is your initial velocity, right? Before hitting. What do you think will happen to the velocity? It will change. So some final velocity will come. Okay. So because of the force applied, what is happening to the velocity? It is changing. What is mass into velocity gives you? Momentum. So this is your initial momentum. What is mass into velocity gives you? Momentum. So this gives you final momentum. कित्याक दोन different momentum आले? Because velocity is changing, no? So it will have two different values. So because of the force applied, what is happening? Momentum is changing. And how do you denote change in momentum? dp by dt. What do you mean by d by dt? Or d by dt जे number येतात त्याका किती म्हणतात? Change in momentum. Are you all understanding? So change in momentum of any body is dependent on what? How much force is applied. Is that clear? So कशी याद दवरतली? Newton's second law. Newton's second law is F proportional to dp by dt. What do you mean by this? Momentum changes when the force is applied. How you will remember this? Based on your bat and ball concept. Is that clear? So read that definition, Newton's second law of motion. According to this law, the force on the body is directly proportional to a rate of change of linear momentum. Rate of change of linear momentum. Don't write. There's a small derivation. I will just solve it here. So F is proportional to, what is P equal to? C. Mass into velocity upon dt. I told you all d by dt is used for what? Something that is changing. D by dt can be used for the quantity that is changing. Now what you have inside this? Mass and velocity. There are two physical quantities. Out of this, who is going to remain constant and who is going to change? Mass is going to remain constant, velocity is going to change. So d by dt दोघांकूय apply करपाक मेळटा काय एकट्याक भायर काडचो पडटलो? एकट्याक भायर. कोणाक भायर काडटली? Mass will come out and you will have dv by dt because velocity is changing, no? And what is dv by dt? Acceleration. So F will be proportional to mass into acceleration. Remove the proportionality sign, you will get a constant. Mass into acceleration. We take this k is equal to 1. So from this second law of motion, you get a very famous formula. Force is equal to mass into acceleration. Is that clear? Yes? Go through it. You got the paper? Not yet? When are your results? Zale? Can we repeat again? Newton's first law of motion was what? Was based on inertia. So what was that? Any body in the state of rest or uniform motion or in the state of motion will remain in that state until An external force is applied on it. So no, see, till now, nothing is there to by heart. Whatever you are going to answer, you're going to answer it in your own words. All those applicative questions as well. What was Newton's second law of motion? You can put it in any way. तशेंच तेजेरूच statement दिल तसो बरोवपाक जाय असो ना. You know that because of the force applied, what is happening? Momentum is changing. So you can put it in any way. What is Newton's second law of motion? The force applied on an object is proportional to the change in momentum of that object. Okay. So from that, we got a very important formula, that is, what is that? Force is equal to mass into acceleration. Now, physics starting 3 chapters, हमका formulas जे असताले, those were not like which can be used further. Vectors भी थोड़े थोड़े असताले formulas, okay? But from now, all these formulas can be used in any other chapters as well. Kinematic equations ये एक असर, which will be used in rest of the chapters. Where rest of the chapters, I think, where you will have to find acceleration, velocity and all, you need those formulas. So what you do is always make a habit for your 11th and 12th as well. Physics as you come across any new formula, you start writing those formulas at the back. Okay, for example, you had first one, kinematic is which one? V is equal to U plus AT. S is equal to UT plus half AT square. V square is equal to U square plus 2AS. This were your kinematic ones. Now what you studied, F is equal to dP by dt. Then you studied F is equal to mass into acceleration. So it will be always better for you all to, when you are going through, you will get a brief idea from there. Okay. Next, we'll talk about impulse. Right. Momentum is clear to everyone? Yes. Like a linear momentum mantata. This is called as what? Linear momentum. What do you mean by linear? Velocity is only in one direction. Then you will study in rotational motion angular momentum. Angular means what? Next is impulse. Impulse is denoted with a alphabet J or I, or just impulse. Okay. Before coming to what is impulse, and I will tell you what questions you get on impulse. Either you will get numericals or you get applicative questions. So I will just tell you one trick to remember how to answer the applicative questions. So let us first come to the formula part of it. Impulse is given as force into time. One formula. What is the formula? Force into time. And second formula of impulse is final momentum minus initial momentum. What is your final momentum? Mass into velocity minus mass into initial velocity. Clear? Okay. So these are the formulas for impulse. For us, impulse formula, first one is F into T. You get numericals on this. F into force into time. And second formula is final momentum minus initial momentum. That is MV minus MU. Can you tell me what will be the SI unit of impulse? Look over here and force into time. Newton second. Force unit is Newton. Second, time unit is second. So Newton second. Okay. Again, it is a vector quantity. Impulse is a vector quantity. Okay. आता applicative questions answer करताना, or before that I'll tell you what is impulse. Impulse म्हणल्यार short time खातीर जेन्ना एक large force exert जाता, that is called as impulse. For a short time, when a large force gets exerted on you, that is called as what? Impulse. What is impulse? Or during a short time, or for a short time when large force gets exerted on you, that is called as impulse. Now coming to the applicative questions, I'll tell you all the tricks. If you take T on the other side, J is equal to Ft, right? If you take T on the other side, where it will go? To the denominator. So it will be F is equal to J upon T. So how is F, and if you keep this J constant, impulse suppose आम्ही constant दवरलो, how is F and T related? Inversely proportional. So suppose आमका force कमी करपाक जाय जाल्यार time किती करचो पडलो? Increase करचो पडलो. This is the trick. This is something that you have to remember when you are answering the applicative questions on impulse. If you want to reduce the force, what you have to do? Increase the time. As simple as that. If you want to reduce the force, because if high amount of force comes on you in a short period of time, you will get hurt. Remember it that way. So तुमका hurt जावपाक नाका जाल्यार किती करपाचे? Force कमी करपाचो. Force कशी कमी करतली? Increase the time. Okay. Now you might feel it little bit confusing. Once we do the applicative questions, you will understand. Go to the next page. Page number 4. Don't write anything. I will give you all time. First question that you can get, a cricket player lowers his hands while catching a ball. Why? A cricket पहिल्या सगळ्यांनी catch करता असताना does the fielder stands like this or lowers? कित्याक खातीर या lower करप? What do you think is happening? अशें धरून, if you stand like this, you are the player now. If you stand like this, what will happen if the ball is coming? तो किती जातलो ball? Thap. It will bounce back, right? कित्याक bounce back जातलो? Because its impulse will be more. Within no time it is coming and falling in your hand. So impact of that force will be more. Time is less, force is more. So either you will hurt yourself or the ball will bounce back. Now what is happening by lowering your hands? You are increasing the time, therefore the force exerted will be less. Is that clear? So any question on impulse, you have to answer the same way. Why does player lowers his hands? By lowering the hands, what is doing? Is increasing the time such that the force is less. Read that answer now. By increasing the time, what is happening? The force on him reduces. Therefore, he will not hurt, not get hurt. Is that clear? Okay. Okay. Next one. A person falling from a certain height receives more injuries when he falls on a cemented floor than when he falls on a heap of sand. Just imagine one person from a top building falls on the floor directly, and or if he falls, suppose सकल sand up, okay, त्या sandaचेर येवन पडटा, where he will get more hurt and where the injury will be less. फ्लोराचेर डायरेक्ट पडलो सिमेंटेड फ्लोराचेर जाल्यार he will get hurt. Where injury will be less, where sand. कित्याक खातीर? What happens when he falls directly on the cemented floor? Within less time, the impact of that floor on the person will be more, or the force on the person will be more. Whereas when he falls on the heap of sand, it takes time for him to go. Heap of sandaच्या वयरूच उडचो ना तो, because of the velocity as well as its weight. What will happen? The heap of sandatlan तो भितर वयतलो pass जावन. Yes or no? So when he's going inside, is he going with the same time? In the previous one, no. It will take time for him to reach the ground. Correct, no? So time increase झालो की impact जो आशिल्लो of the floor that was exerting on him will become less. Clear? Read it. Right? Done. Next one. Automobiles are provided with shockers. What are shockers? They are also called as shock absorbers. Aikala. Suspension. So why are those suspensions or shock absorbers provided to the vehicle? You all will be in a better state to answer that. Huh? Potholes, yes. So roadacher potholes असतात. So suppose shock absorbers or the suspensions were not there. I have no idea like how they look, but I feel it will look like something spring kind of thing. Yes, yeah. Where? Okay, fine. Yeah, so it will be kind of spring kind of thing. Jenna, our roads are not the smooth ones. Okay, so suppose potholes असा तिथून गाडी गेली मधी त्याला किती जातले? If those suspensions were not there, the jerk direct आमका लागता आशिल्लो. Those were sitting inside. So when those suspensions are there, the jerk goes first where? To those suspensions. Okay, so the time jo asa for that force to reach towards, jerk to reach towards, that increases. As a result, that force, jerk decreases. Okay, so that is the reason why shock absorbers or suspensions are used. Read it. You get this question, sir, for the exam. But by mistake, inertia applicative question answer boron do nakat. Now why the rider falls backward? Because of time increasing and force decreasing boron do nakat. That is another concept. This is another concept. Okay, buffers are provided between the bogies of a train. Why? दोन compartments मध्ये similar to the suspension. There will be those buffers placed. Without buffers किती जाता आशिल्ले? Compartments एकमेकाक dash जाता आशिल्ले. So when those bogies are there, what happens? Oh, sorry, when those buffers are there, what will happen? Time between the when they are moving, time between them increases. So force exerted on each other will decrease because it is again the same type of concepts. What is that spring kind or that suspension type of concept? Read it. Done. Last one. Chinaware and glassware are wrapped in straw paper before packing. What are Chinawares? Dinner sets पहिलं. Those are Chinawares. Now these straw papers, I don't know whether you all have seen it. Brown color असतात strips असतात. Or you can even take those bubble wrappers. They are also play a same kind of they also have a same function. So why are those wrapped? Fragile items असतात, glass items बी असतात तेका ते bubble wraps असतात mostly. So why are those bubble wraps or why those straw papers are being kept? Even that will have similar type of thing, I think. Tube lights or त्या काय बी असतात, bulbs बी पहिले येताले पळय, तेंकाय असताले the same time. So why do you think that is there? हांगा Chinaware or dish, what is that? Glassware म्हणलं. So they have been transported, no? If that was not there, suppose plates were put together, dinner plates were put together in a single box without those packing separately. Are they going to put it nicely? Okay, this is a dinner set during the transportation that I will put it. No, that is not possible to take care of. So what will happen inside? They will break. So to avoid that, each one is put in a different those straw papers. Okay, so what increases there? Time increases. When they dash each other, time increases and impact or the force that is exerted on each other decreases. So they will not break. Okay, same answer. This one. Read it. What is the formula for impulse? F into T and final momentum minus initial moment. So let us derive this one. Second formula derivation you have. Just pay attention here. Small derivations you all have here. You know force is equal to mass into acceleration. What is your acceleration formula? V minus u upon T. So I will substitute it here. A is equal to V minus u upon T. Here there is multiplication, no? So this T I can take this side. Can I multiply M inside? So what it will be? MV minus, what is F into T? Impulse. What is MV? Final moment. What is MU? Initial moment. Hence, from our second law of motion force formula, we have proved that impulse is final momentum minus initial moment. Okay, solve. Now write. झाले? Done? Now rub this. Find impulse in these two cases. I'll tell you how to find. Find impulse. Yes. or calculate impulse. Okay. So make a note and write. Area under FT graph, FT, force time graph. Area under FT graph. Area under FT graph gives impulse. Area under FT graph gives impulse. Okay. If I want to find impulse here, first case, what I have to take? Area under this graph. So what area is this? Triangle. So it will be what? Half length into breadth. Here if I want to find impulse, area under FT graph. So this is my graph. What it is? What? Length into breadth. It's not a square. Okay, this is a square, but it is 10 and 5. So it will be length into breadth. Okay. So put the value. So if you get a graph of FT and they ask you impulse, then see that you have to take the area under the. Solve. First one, give that answer. Half 20 into 10. So 100 Newton second. Second one, 10 into 5. So 50 Newton second. So all are getting this answer? Okay. आता मी थोडे न्यूमेरिकल सॉल्व करूया on this part. Page number 4. Can you see these questions here? Start from question number 1. You all have to read. Huh? So either you can get it in graph or you can get it through the questions. Can I rub this? Do not jump to solve the questions directly. Pahili read karat, understand kurun घेयात question. Reading is more important and understanding the concept. A hammer of mass 1 kg moving with a speed of 6 meter per second strikes a wall and comes to rest in 0.1 second. So try to understand the concept first. There is a hammer which has been thrown towards a wall. So what are the things that are given with respect to the hammer? It is thrown, it hits the wall and it comes to rest in so and so time. So what is given about the hammer? Kitlo do? 1 kg. It was moving with how much velocity? 6 meter per second. So which velocity it will be? Initial or final? It is hitting and coming to rest. Final velocity will be 0. In how much time all this thing happened? 0.1 second. So this is the data given to you. You have to find the impulse of the force. J you have to find out. The retardation of the hammer. So what is retardation? Acceleration. फक्त negative sign इथली. Okay. Retardation find out करपा different formula ना. It is the same formula which you find acceleration. Retarding force that stops the hammer. Third thing what you have to find out? Force. Retarding force is nothing but a force. So which you can find first? Acceleration first find out करतेली कशी करतेली? V minus U upon T. Okay, fine. Solve it. F somewhere you got. आणि किती उत्तर बोललं नाही force. So what is retardation that you are getting? A will be V minus U upon T. V0 minus 6 upon 0.1. So that will be minus 6 upon 0.1. So decimal point एक shift केलो जाल्यार किती जातले? Decimal point 1 shifted. Numerator you will get 1, 0. So denominator will go. So this is your meter per second square. So are you getting acceleration over here like this? Minus 60. No. kg is SI unit. No? Then what you can find out next? Force find out career. Force is mass into acceleration. So mass is 1 into acceleration is minus 60. So answer will be minus 60 Newton. Correct? Last one, J. MV minus MU करपाक मेळटाले. Starting सुद्धा find out करपाक मेळटाले. Which formula you would have used? MV minus MU. Or now you can even use what? F into T. Anyone, both will work. F into T. So minus 60 into 0.1. So minus 60, this decimal point 1 shifted, it will be 10. So 0, 0 got cancelled out, minus 6 Newton. Done? Read the next one. You all try to solve it. Then I will. Try. Don't wait for me to solve every time. Think that you're answering a paper. All the formulas, everything is written at the side over there. You have not got one book, you said. Impulse is asked. See, always start from what is asked. Force. So you have to start with the formula of force. Then you have to keep on searching where you can get, from where you can get that value. Correct, solve. Correct. What is asked over here? Force, right? Resistive force. A bullet of mass 0.04 kg moving with a speed of 90 meter per second enters a heavy wooden block and is stopped after a distance of 60 centimeter. What is the average resistive force exerted by the block on the bullet? So there is a block over here, wooden block. One bullet comes and it enters, it moves for some 60 centimeter and it stops over here. What are the things given? Mass of that bullet is given 0.04 kg. What else is given? Initial velocity is given 90 meter per second square. It is coming and stopping here. So final velocity will be 0. Anything else is given? How much distance it has covered? 60 centimeter. पहिली सध्या हो centimeter is not your SI unit. So that has to be converted 60 into 10 raised to minus 2 meter. Okay. Now what is asked? Force. फोर्साचो फॉर्म्युला किती किती असता एक तर dp by dt or your mass into acceleration. Mass is given to us. Do you have acceleration? How you will find acceleration? And all those values are given to you. Distance is given, initial velocity is given, final velocity is given. How you will get acceleration? Which equations? Here things are given. Which equation? V square is equal to u square plus 2as. You'll get a from there, substitute it over there. V square is equal to u square plus 2as. V is 0, U is 90 into 90. 60 into 10 raised to minus 2. So if I take one term on the other side, it will be 2a 60 into 10 raised to minus 2 is equal to minus 8100. Now a will be minus 8100 upon 2 into 60 into 10 raised to minus 2. Solve this and tell me the answer. Kitlo? Minus 45? 45, that's fun. 6750. Where's your 2? Six seven 50 meter per second. Now, don't write the answer directly. Please solve and see if you are getting that answer. 10 raised to minus 2, you can keep as it is. 10 raised to minus 2, you can keep as it is. Then you can shift the decimal point. Just solve this part. How 0, 0, so the cancel karpak meta directly. You're left with minus 810 upon 2 into 6. And here it will be 10 raised to 2. Or 81 by 12 also you can do. That also can do. So you can basically do this as minus 81 upon 12 into 10 raised to 3. So just divide 81 with 12 and tell me what answer you are getting. 6.7 something you will get. Six seven five zero minus. Now this you substitute here. This will be 0.04 into minus 6750. Now don't directly multiply 0.0. Just shift the decimal points and then multiply. So this will be minus 6750 into 4. 2 decimal point shifted. So it will be 10 raised to minus 2. This you keep as it is. Just multiply 4 with 6750. Or just multiply 675 with 4. 10 raised to minus 1. Then. And tell me the final answer. What? Hmm? 270 minus 270 minus 270. Clear? Now just pay attention for the next one. The motion of a particle of mass m is described by y equal to ut plus half gt square. Find the force acting on the particle. आणि काहीच सांगू नका. What do you think is that y? Motion of a particle is described by this equation. So what do you think is this equation? Which is this physical quantity? It is your displacement. Motion is given by what? Displacement. So this equation is your displacement equation. Clear? Okay. Now again they have asked force. So force also formula किती जातलो? Mass into acceleration. They have said a particle of mass m. So m will remain as it is. Correct? They have not given the value. Now what you have to find out? Acceleration. Displacement is given. You have to find out acceleration. How you will find out? Equation as the equation. So how you will find it? What is acceleration? When you differentiate your velocity equation, you get what? Acceleration. But do you have velocity here? No. How you will get velocity? When you differentiate your displacement equation, you get velocity. Okay, so you have to differentiate it 2 times. So let us try. So how you will find velocity? You have to differentiate your displacement equation. You will get velocity. So what it will be? ut plus half gt square whole upon dt. Correct? Can you tell me what is the derivative of ut? What was the derivative of 2t? 2t by dt it is a short form something. What was the derivative of 2t square? This 2 we had to write as it is. And what was the derivative of t square? 2t. So this was 4t. Yes. What was the derivative of 2t cube? 2 you write as it is. What is the derivative of 3t square? T square, t cube? 3 t raised to power असतो -1 करत. So 3 असतो कितलो जातलो? 2 जातलो. So answer will be 60 square. What is the derivative of at square? A I'll write as it is. What is the derivative of t square? 2t. So answer will be 2a. Clear? What is the derivative of at? Power na zaल्यार t will go. Think that way. Yes, you all remember, right? So what will be the derivative of ut? What will be the derivative of half gt square? What is constant first of all? Half is constant. Again, g is constant. So what is it? जशे आम्ही 2t square किती केले? 2 असतो असं बरेलो. And then t square we were differentiating. Similarly, half g I'll write as it is. What will be the derivative of t square? 2 into. So this 2 got cancelled out. So what will be your velocity equation? U plus. Stop करपाचे हांगा. Then what you have to find out? Acceleration. How you will find acceleration? Differentiate your velocity equation. So it will be d u plus gt upon d. Sanga data, what is the derivative of u? Is there a t with it? No. T now mallar u is a constant term. So what is the derivative of constant? Plus what will be the derivative of gt? So your acceleration is equal to g. So what will be your force here now? Where I'll write here. Force will be mass into acceleration, and your acceleration is nothing but g. So m. Okay. This is nothing new. I don't know whether those who have joined new recently, तुमका हे कितले कळतं ते, but you all, I think your others are well versed with this. those who have already got the papers, the subjects you all have opted here in our coaching classes, ते तुमचे नाव आणि मार्क्स बरेया थांग. Okay. Meaning if you have opted only PC, write only for PC. If you have taken PCB, write for PCB. Or all 4 subjects and write for all 4 subjects. No, this is for parents meetings. Swizzle you read. If you are done with this, solve the next question. Question looks simple, but logic apply करपाक जाय. So think properly and answer. Answer is not 0. I know maximum of you all must have got the answer 0. And we got the correct answer. Impulse is asked, right? Impulse चे 2 formulas असतात. One of them you have to use. But understand the concept first. Okay, this सांगता. A ball is been hit by a batsman. Mass of the ball will remain same. So he hits it back with a same initial velocity towards the bowler. Genial. Anyone is getting a different answer? Yes, मेळटा न्ही कोणा different answer का 0? कितलो मेळटा? Minus कितलो? 1.1 minus 1.8 मेळटा. सगळे पेपर आउट ऑफ 20 आशिल्ले न्ही ऑल दी कॉलेजेस. हा इम्पल्स फॉर्मुला खंयचो यूज करतली. टाइम इज नॉट गिवन. So it will be mv minus mu. मास कितलो दिला 0.15 kg. Now the ball comes with velocity 12 meter per second. The batsman hits it and the ball goes with the same velocity towards the bowler with velocity 12 meter per second. The velocity is what type of quantity? What type of quantity? Scalar or vector? Causal magnitude, which is equal. What about its direction? What about its direction? This is going along positive x-axis. How positive getla? How kiti घेवपाक जाय? Negative, no? Both are going in opposite direction, no? This is along positive x-axis. This is along negative x-axis. Solve it. No? What is the answer? So this will be minus 0.15 into 12 minus 0.15 into 12, which you can write as minus 2 times 0.15 into 12. 2 times, no? Same value. Multiply 3.6 Newton Fine. So what was Newton's first law of motion? Anybody in this? Everyone answer. Anybody in the state of rest or uniform motion will remain in that state until an external force is applied on it. What was Newton's second law of motion? Change in momentum in any body is said to be proportional to force applied on that body. Okay. F proportional to dp by dt. Remember that. What is Newton's third law of motion? Every action has equal and opposite reaction. Okay. Action and reaction has to be done on the same object or two different objects. Same object. If I hit myself, I will hit myself. Action and reaction की दाते जावपाक जाय. Same objects or two different objects? Two different. It cannot be on the same object. It has to be on two different objects. Two different means it has to be combination of two objects. If there are two objects, A and B, so A will exert a force on B, and as a result, B will also exert a force on A. If I slap someone, someone will slap me. So this is force on B due to A. This will be force on A due to B. Correct? Force on B due to A. Force on B due to force on A due to B. What you can say about both the forces? They will be equal but in opposite direction. But in opposite direction. Is that clear? Now can you tell me what is FBA? Force on B due to A. How you will put it in other words? B chair. Force कोणे apply केलो? A has applied the force on B. Whose momentum is going to change here? Of A or B? What I'm doing, everything, point by point is important. When I say force on B due to A, who applies a force on whom? A applies a force on B. Whose momentum will change? Whose momentum will change? A or B? Understand this. Who is applying a force? Bat was applying a force on ball. Bat was applying a force on ball. So whose momentum was changing? Of bat or ball? Ball. So A is applying a force on B. So whose momentum will change? Momentum of B will change. When B applies a force on A, whose momentum will change? Momentum of A will change. All these things are important. Okay, quickly, we'll do just one or two applicative questions on it. Okay. While walking, हांगा तुमका चडशे examples विचारतात. Okay. Or they might ask you like this: while walking, a person presses the ground in backward direction. Why? How you walk? What application is this? Newton's third law of motion. When you press one leg, ground is also exerting a force on you. As a result, your other leg comes forward. Is that clear? So that is how you walk. Swimming. How you do swimming? What do you do? What you are doing? With the hand, you are pushing the water backward. As a result, reaction force will be water will push you forward. Okay. Similarly, read the other one. Or just read Karat. It is not exactly this point. A book lying on a table exert a force on the table which is equal to the weight of the book. This is the force of action. The table supports the book by exerting equal force on the book. This is the force of reaction. Now, what I had told you all last time. If I keep a bottle here, it is not falling down. Why is it not falling down? Which are the forces present? Weight of this bottle is acting downward. Correct? So who is providing a reaction force to this? The table is providing a normal force, reaction force to, that is that third point. Then firing from a gun. What happens when you fire? You must have not done it, but must have seen it. Huh? When you fire a bullet, bullet goes forward. What happens to the gun? Comes backward. Gun is exerting a force on bullet. Bullet is also exerting a force on gun. Why does the gun doesn't come back with the same force, with the same velocity? Bullet वयता त्याच velocity तो फाटल्यान कित्याक येना? This you will learn in conservation of linear momentum. Very important topic. Okay, correct no? Bullet ज्या फोर्सान वयता तितल्याच फोर्सान gun येवपाक जाय. Velocity gun येना. So that you will study that. But that is one of the example. Flight of jet planes and rockets. What is this? Jet planes, rockets, failure. What comes out from there? Backward. Fume. Escaping, the gas escapes out, right? So with a force that escapes out, which gives a push to the rocket to go up. Okay, so those are the examples of Newton's third law of motion. Okay, we'll end it. Just a minute, I'll take attendance and then leave you. हाँ सर तो बटन Thank you.